The fatigue fracture mechanics here, what we're talking about here is you have a crack, but then you oscillate the loading um, conditions, and that causes the crack to close and open, and that's going to cause a crop propagation that occurs due to fatigue. Uh, I'll just point out that when you have this structure and you have loading cycles applied that look like this one here, the crack will grow with the number of cycles. Um, and you can turn this plot into a DADN K curve. This is called the Perry's law relationship. The crack length increases because you're cyclically loading the structure. So the DADN curve versus A, that can be converted into something called the Perry's law relationship, and I'll go into that in a minute here. And on the right, I show the DADN relationship. So delta K1 is a range of the stress intensity factor. A is a crack length, N is the number of cycles to failure, while A, big A, and small m, those are constants that can be measured in a test. Uh, crack initiation and fatigue to failure and failure due to fatigue of that crack that initiated accounts for a large number of mechanical failures attributed to fatigue. We're going to assume that linear elastic fracture mechanics is valid, and we're going to use Perry's law relationship here in the bottom. You can perform this test cyclically to then measure the values of C and M. And when you do, you get a curve. When you do the testing, you get a curve that looks like this. You have DADN in the y-axis, you have delta K in the x-axis, and this was done for different R ratios. What that R ratio means is the minimum stress intensity factor divided by the maximum intensity factor. This zone that's linear is called the Perry's law region. And when you approach higher crack growth rates, sorry, the system becomes unstable and the crack propagates. But the main equation to use is this one here, DADN equals C times delta K to the M power. C here, again, C here, and M can be found through testing. They're empirical. You can then integrate this relationship to calculate the number of cycles to failure. So given the initial crack length, you can determine what the final crack length is, and you can also calculate the number of cycles to failure. That's pretty much it when it comes to fatigue fracture. I have a whole lecture series on fracture mechanics. I invite you to take a look at that. In the meanwhile, I want to thank you for a very successful course, and I hope you reach me out for questions. In the meanwhile, I want to thank you again for your attention. Have a great rest of your quarter system, and looking ahead to meet you up again.